So we're going to do 2015 number 4. A researcher conducted a medical study to investigate whether taking a low-dose aspirin reduces the chance of developing colon cancer. As part of the study, 1,000 adult volunteers were randomly assigned to one of two groups. Half the volunteers were assigned to the experimental group that took a low-dose aspirin each day, and the other half were assigned to a control group that took a placebo each day. At the end of 6 years, 15 of the people who took the low-dose aspirin had developed colon cancer, and 26 of the people who took the placebo had developed colon cancer. At the significance level of alpha equals 0.05, do the data provide convincing statistical evidence that low-dose aspirin each day would reduce the chance of developing colon cancer among all people similar to the volunteers? Okay, so this is a two-sample test for difference in proportions. So you first need to start by stating that. So you need to state what your first proportion is and your second proportion is. So you're going to have a P1 and P2 here. So P1 would be the true proportion of adults who develop colon cancer when given aspirin each day for 6 years. Our proportion 2 would be the true proportion of adults who develop colon cancer when given a placebo each day for 6 years. And then P1 minus P2 is the difference in proportions of developing colon cancer. Our null hypothesis is P1 minus P2 equals 0. Our alternative hypothesis is P1 minus P2 is less than 0. We need to find P hat 1, which was 15 over 500, because they stated it up there, which equals 0.03. P hat 2, which is 26 over 500, which is 0.052. And then our P hat is 41, because we add 15 and 26, over 1,000, which is 0.041. We're doing a two-sample z-test for comparing proportions. With an alpha level of 0.05. We do need to check conditions. Every time you either do a test or a confidence interval, you have to check your conditions. So the first one, 1,000 adults were randomly assigned to two different treatment groups. 1,000 adult volunteers is less than all adults. And N1 P hat 1 equals 500 times 0.03, which equals 15, which is greater than 10. N1 Q hat 1 equals 500 times 0.97, which equals 485, which is greater than 10. You also have to check N2 times P hat 2, which equals 500 times 0.052, which equals 26, which is greater than 10. N2 times Q hat 2, which is 500 times 0.948, which is 474, which is also greater than 10. Next, we need to go through, and you're going to write your formula for Z. So this is P hat 1 minus P hat 2 minus P1 minus P2 all over the square root of P hat Q hat times the square root of 1 over N1 plus 1 over N2. Then you're going to go ahead, I don't like how that looks, and plug everything in that you have. So 0.03 minus 0.052 minus 0 all over the square root of 0.041 times 0.959 times the square root of 1 over 500 plus 1 over 500. And yes, you can write this many different ways because you did see the formula in different ways. This equals negative 1.754. You are going to use your calculator to do this. So if you can get out your calculator now. So again, you would go to Stat, you'd go over to Test, and we go down to a 2 proportion z-test. And you're going to have to put everything in. So x1 and then n1. So x1 would be 15, 500, and then x2 would be 26, n2 would be 500, and we're going with less than, calculate, and we get our z value of negative 1.754. This right here is your p value. This is p hat 1, p hat 2, total p hat, which we found right here, then n1, n2. To find q hat, you just do 1 minus those. Okay, so this right here, this p, is your p value. So we'd state our p value equals 0.03969. Okay, then you would have to state our p-value is less than alpha because our p-value of 0.03969 is less than 0.05. So we reject our null hypothesis. And there's significant evidence to suggest that the proportion of adults who take aspirin would develop colon cancer is less than the proportion of adults that do not take the aspirin. So this is everything you have to do to get this problem correct. And this is how you should be doing all your hypothesis tests.